Okay, so we're going to learn about roots and zeros. Um, the main idea to understand is that roots and zeros are the same thing, and factors are similar to this. But what I want to hurry and show you is how we can find those. So what that means when it says zeros, what we're really trying to find is when does y equal 0? Or for what x values does y equal 0? So for what inputs does our output, our range value, equal 0? So the way we can do that is we just put this equal to 0, and then we solve this. So in this case, I can factor by grouping because I made the problem to be that way, but also you can see that each of those are divisible by 3. So I take out a 3x squared and I get x plus 2. Over here, each of these are divisible by 27. So if I take out a 27, I get x plus 2. So now from each of those, I can pull out an x plus 2. So I pull out an x plus 2 from each of them. So if I take this, if I think of it like this, now inside of the brackets, because I pulled the x plus 2 out, I'm left with 3x squared minus 27. And so really I can just put each of those. Remember, once we get it factored, we can put each factor equal to 0. And I get that x equals negative 2. Add the 27. So I'm going kind of fast. This isn't really one of your problems. It's just what I wanted to show you. So x squared equals 9. So if I take the square root, x equals plus or minus 3. So those are the zeros or the roots. To give you an idea of what that means graphically, if I go to Desmos, I've already got it typed in. Notice these 3 points. This is where it crosses the x-axis. The y value on all of these is 0. So notice it's negative 3, 3, and negative 2, the same things we got here. So roots and zeros are the same thing. In a similar sense, factors are also similar to roots and zeros because once you've got the factor, you can solve. And so when they say, what are the factors? Really, you can go from the zeros and you could say, well, the factors would be x plus 3, x minus 3, because that would give us that, and x plus 2. So those are the factors, roots, and zeros. So now let's come to our first question. This one, let's go ahead and close the other one. Realistic domain, we don't need that one. So now what we have is it says roots and zeros from the graph along with a review of quadratic formula. So question 1, the police department uses a formula to determine the speed at which a car was going when the driver applied the brakes by measuring the distance of the skid marks. The equation, yada yada, models the distance, excuse me, d in feet traveled after applying the brakes in a car moving x miles per hour. So how long will the skid marks be if the car is traveling 75 miles per hour? So x is the speed of the car, and we want to find out what d is. So I just have to go d equals 0.0014 75 squared plus 75, and that's going to give me the distance of these skid marks. So I can go right to my calculator and type this in, 0.0014 times 75 squared plus 75. Enter. Oh, that's not the place I wanted it. So 0.0014 times 75 squared plus 75, enter. So 82.875 feet. So this thing's going to travel 82.875 feet. So the distance it goes is 82.875. You'll have to look on the Canvas quiz to what I said to round to. If I say round to the nearest whole number, it's going to be 83 feet. Okay? It says that's how far. So there are 83 feet of skid marks on that. Now, question number 2. A bike is going to jump over a group of teachers laying down in a row next to each other, kind of like the last If you did watch the last video, it's the same problem, but we're going to ask something different. The height of the bike follows a path which is parabolic, and because the bike needs to clear all the teachers, it must clear at least 4 feet. The equation that represents this is that how many times does the bike cross the 4-foot threshold? So all that we need to do is go to our graph, negative 9t squared plus 14t. Okay, so I've come to my Desmos calculator. I've typed in negative 9x squared plus 14x, and I'm looking on here. It says, the question said, how many times does it cross the 4-foot threshold? Well, here's the 4-foot threshold. It crosses it here and here, so it crosses it twice. One at whatever that time is, 0.378, and the other at 1.18, roughly. You know, if I could probably zoom in on it, get a better idea. So if you wanted even, you could probably zoom in even more and get a better, so 1.177. So anyways, the question just says, how many times does it cross that? Twice. And that's it. You don't have to do anything more. If we wanted to actually find the time, you would set it equal to 4, because we want to know the height when it's 4 feet. And you could solve this using the quadratic formula, and that would actually give you the time that we just saw in the graph. So different ways to do that. So this says LeBron James, the height of LeBron James' best dunks roughly follows the parabola modeled by the following function. So this is the height in respect to time, where t is time and h of t is the height above ground in inches. So times our input, height is the output. Based off of this equation, how long is LeBron in the air on his best jumps? So air time. And what is his maximum height? Okay, so we could do this two ways. One way is we could just set this equal to 0, and that's going to give us our maximum air time. So if we did that, negative 207.94 t squared plus 191.30 t equals 0. So now I just solve this. I take a t out from each of those because they each have a t in common. And now that I've got it factored, I can put each factor equal to 0. So at time equals 0, we know he's at 0 feet off the ground. And then he's going to be at 0 feet again when he lands. And so now I just solve this, 191.3. Whoops. So those are gone. So I'd have 207.94 t equals negative 191.3. And so then I'd go to my calculator. And would divide each of those over to the other side. So I'd divide negative 191.3 by 207.94. And that tells me that he's in the air for 0.92 seconds. Okay, so he's in the air for 0.92 seconds. His maximum height is going to be right when that's split in half. So if I take that value and divide that by 2, that's the maximum value. So at 0.46, that's the time when he's at his maximum value. So if I write it into this original equation, negative 207.94 times 0.46 squared plus 191.3 times 0.46. So what I've done is I've taken the original equation and plugged the time in when he's going to be the maximum height, because he's at the maximum height halfway through the amount of time he's in the air. So then I hit enter, And it says he's approximately 44 inches above the ground. Now the next way is just to go to Desmos and type it right into there. So I type in negative 207.94 x squared plus 191.3 x. And I have my graph. And I'm going to zoom in a little bit at the bottom so I can click on that. So 0.920, so that's the time that it's in the air. So that's what we got right here. So he went up, came back down around, and landed. So his height above ground is 0 at both places. So it took 0.92 seconds. And then I can come up here to the top, and it says at 0.46 seconds, which was half. Remember that we said it was halfway from the total time, and his total height is 44 seconds. So that's the other way we can do it, is just graphically look at it and find the answer. So question number 4 says a group of elementary students are playing a game of kickball. The ball is kicked from ground level, and the height follows a path modeled by this equation where t is in seconds and the height is in feet. So the ball does something like this as far as its height, and this is time. So at time is 0, the ball leaves, and at 0 it comes back down. That's the height. Sorry. We don't know the time, but we know the height is 0 at both places. And here's the time is 0, and then here we don't know yet. The ball will clear all the hands of the elementary age kids playing the game when it is above 7 feet. So somewhere like this. This is our 7-foot threshold. Okay? At what point of time is the ball exactly 7 feet above the ground in seconds? So again, we can do this two ways. We can use, we plug 7 in as our height. So 7 equals negative 9.89 t squared plus 25t. Now we make it equal to 0. So now I have negative 9.89 t squared plus 25t minus 7 equals 0. So I have this is A, B is 25, and C is negative 7. So now I can plug that into our quadratic formula, which says negative b plus or minus the square root of b squared minus 4ac all over 2a. So what I have is negative 25 plus or minus the square root of 25 squared minus 4a c, which is negative 7. And all of that's going to be over 2a. So now I just go right to my calculator. Come on, calculator. So I'm going to have parentheses. I'm going to do all of the top in one parentheses. Negative 25 plus second square root of 25 squared minus 4 times negative 9.89 times negative 7. I'm going to go out of the parenthesis, out of the square root, close the parenthesis, divided by parentheses. So now I'm going to put all the bottom in parentheses. 2 times negative 9.89 and close the parenthesis. Now I hit enter. And it says at 0.32 seconds it crosses. And then I hit second enter. And I hit second arrow, moves it all the way to the left. And I'm going to change that plus to a minus because I need to do the plus minus case. So now it's a minus. So it crosses. Come on. So it crosses that 7-foot threshold at 0.32 seconds and at 2.2 seconds. So anywhere between those, so between that time and that time, it is above 7 feet. Nobody's going to catch it. So it's just this little bit of time here and here that somebody could catch it. So now, those are my answers. If you wanted to see another way to do that, what we do is we go to our calculator here. We're going to clear this off. We're going to type in negative 9.89 x squared plus 25t. So I go negative 9.89 0.89, and I don't have a t, so I'm going to use an x squared plus 25x. And it's not even showing up, but until I come down here, and there it is. So I'm going to zoom in a little bit. So there it is. There's 7 feet. I can't see it. So 0.32 seconds. And then over here at 2.2 seconds. So that's how we can do it graphically as well. Okay, so I can just type it in, come to these points, and there it is. On the other calculator that you have, it's a little bit harder to do. You can just hit trace though and find it that way as well. Okay, so anyways, that's the answers for number 5 are 0.32 seconds and 2.21 seconds if we round all the way over. So number 5 says the height of a ball thrown from the outfield in a game of baseball follows a parabolic path. So the height, modeled by the equation, here it is, where t is in seconds and the height is in feet. The optimal height for the catcher to catch the ball is at 2 feet above the ground. At what time does this happen? So if I graph this, that's one way to do it. Or the other way is, again, to set my height that I want to be at 2 feet. And I'm just going to use x's. So now I get it equal to 0 because that's how it needs to be so that we can solve this, is it needs to be equal to 0. So I now have my equation set up where A is negative 5.877, B is 19.394, and C is 6. So again, I go to my calculator, and I probably should write that into the quadratic formula first so you can see what I'm going to do. So negative B plus or minus, whoops, negative B, I need to write all of B, come on. I make a lot more mistakes because you guys aren't here in class to catch me when I make them, so sorry about the mistakes. Negative 5.877. So b squared minus 4ac all over 2a. So now I just type that into my calculator. Again, all of this top stuff is going to be in parentheses, so I put it in parentheses. Negative 19.394 plus the square root of 19.394 squared, so that's the b squared, minus 4 times a, which is negative 5.877. Whoops, one too many. Times 6. Then I'm going to go out of my square root, close my parentheses, divided by 2 times negative 5.877. And now I hit enter. So it says at negative 2.85 seconds, it's at 2 feet. So that doesn't help us any. That's like saying the outfielder caught the ball running and it was down below, and then he has to stop and bring it up high and leaves his hand at 8 feet. So we don't care when he caught it. We want to know when it's going to make it to home plate. So I hit second enter, and then I hit second back arrow. Remember, that moves us all the way to the front. And I can change that plus to a minus. So there's the minus. I hit enter, and it tells me it happens at 3.58 seconds. So when does this get here? At 3.58 seconds. And again, as I've done on the others, I'll show you how this works on a graph as well. So all that I'm going to type in my graph is this part, and then find out on the graph when it crosses the 2-foot threshold. So I come to my graph, clear that one off, type in negative 5.877x squared plus 19.394x plus 8. Then I'm going to come down here, and here it is, right? This is 2 feet high. So if I look at it, here's 0 feet, here's 4 seconds. 2 feet high is right here. So 3.58 on this. Okay, if I zoom in a little bit more, get a little bit more accurate, 3.584, so that doesn't round up, so it would be 3.58 seconds. Okay, so that would be my answer, 3.58 seconds. So what time does this happen that the catcher catches it? 3.58 seconds from the time that the guy released the ball out of his hands. So the easiest way to find out, if I look at this question, sorry, it says graph the equation. How many root zeros does the equation have? So I'm just going to go right to my calculator, type it in. So 5x to the third minus 17x squared plus 2. So there it is. I'm trying to find out how many times it crosses the x-axis. 1, 2, 3. That's all I have to do. It will never cross more than the highest power. Okay? So whatever that number is, it will never cross more than that. It can cross less, but it can never cross more than that. If it crosses less, it'll always be less than 2. So for example, if I have a graph, it could look like this, okay? Because there will always be 2 turning points. So this 3, 1 less than that number is the number of turning points. So 1 less than the highest power is the number of turning points. So if we have it to the 4th, it could turn 3 times. So I could have 1 turn, 2 turns, 3 turns, 4 turns. So that's next to the 4th. Or it could look like this. It could be something like this, where it never crosses at all. Or it could be like this, where it crosses there and there, and it doesn't cross in the middle. So it always, if it doesn't cross, there's always 2 less than whatever it is. Like this part right here didn't cross, it takes out 2 answers. This part didn't cross, it takes out 2 answers. But anyways, the answer to the question on the 1 is just 3. This crosses 1, 2, and 3 times. And if I were after those points, there they would be. So I come back to here. The answer to number 6 is 3. Number 7, it says graph this, so I'm going to just graph it real fast. So I type it in, 5x to the third plus x squared minus 13x plus 8. So notice this doesn't cross. It can only have a maximum of 3 points, so there it is, right there. So it crosses 1 point. So number 7, the answer is 1. Number 8 says graph the following using your graphing calculator. Identify all the roots of the equation. So we're going to do the same thing. So we're supposed to identify all the roots on this one. So remember, the roots are where it crosses the x-axis. So we're just going to go ahead and graph it like we have been doing. So I come to my calculator, the Desmos one, 3x to the 4th. You could use your other one as well. It actually has a roots button on there that you can use to find them. So you just have to type it in and say, then you have to tell it to calculate the roots of it and tell it between which boundaries. So talking and not paying attention to what I'm typing, 49x squared plus 35x plus 98. Make sure those match up. 3x to the 4th minus 15x cubed minus 49x squared. All right, so it looks like it crosses at -2, negative 1.528, 1.528, and 7. So my roots are going to be x equals -2, x equals negative 1.528, x equals 1.528, and x equals 7. So now I just go back and I write those down, and those are the four answers. And it couldn't have more than four because that power is 4, the highest power is 4. Question 9 says the same thing. It says go ahead and graph this. So we go to our calculator. So back to my calculator, I clear this one off. Come here to x cubed plus x squared plus 9x plus 9. And it only crosses at one time, which is at negative 1. So we could zoom out and see where the bend is, see if there's anything at all. Not seeing anything, but I'm not seeing that it crosses anymore, so I think the 1 point is pretty good. So it crosses right here at negative 1. So identify all the roots of this equation, x equals negative 1, which makes sense that there's missing 2, because remember how I said it would either be the 3 or 2 less, so it's 1. Now it says, given this equation, find the value of x find the value of x when y is equal to 4. So again, remember that that's when we could just take this and say 4 equals negative 5x squared plus 8x plus 4. Now I'm going to minus the 4 over. And I get negative 5x squared plus 8x equals 0. So now to solve that, I factor out an x, and I get negative 5x plus 8. So x equals 0, and negative 5x plus 8 equals 0. So now I minus the 8 to solve. So I have negative 5x minus 8, equals a negative 8. Divide by negative 5. So a negative divided by a negative is a positive, so x equals 8/5. So x equals 1.6 seconds. Or not 1.6, it's just seconds. It's just 1.6. So the y value is equal to 4 at x equals 0 and x equals 1.6. Again, I could just graph this part. So let's just do that real fast. Go to this calculator, come on. Clear that one off, type this one in. I get negative 5x squared plus 8x plus 4. So when does the y value equal 4? Right there and right there, which is 1.6, if you could see it behind my little cursor there. So 1.6 is the y value equals 4, which is what we have. So that's how you can do it both graphically and using your calculator. Okay, so this last question, it says, a May's arm throws a baseball as high into the air as he can. The height of the ball with respect to time follows a parabolic path and reaches a maximum height of 200 feet and stays in the air for 8 seconds. The x-axis represents time, the y-axis represents the height of the ball. The equation is this: when does the ball cross the height value of 100 feet? So again, I'm just going to put 100 in place of f of x because this is the height. So I can replace that f of x with the height equals negative 12.5 x minus 4 squared plus 200. So now I'm just going to, since this is squared and I don't have any other x's, I can just get this stuff alone to solve. So I don't have to use the quadratic formula because there's only one thing that's being squared. So now what I'm going to do is just minus that 200 from the right so that it's gone. What I do to one side of the equal sign, I do to the other, so those are gone. So negative 100 equals negative 1.2 x minus 4 squared. So now I divide it. I have to divide before I square root because I have to have just this stuff alone. So I divide it by negative 1.2. So I go to my calculator, and a negative divided by a negative is a positive. So I'm just going to go 100 divided by 1.2. So what I have now is 83.33 equals x minus 4 quantity squared. So to get rid of that quantity squared, I just square root each side. So I square root it. So what I'm going to do is I'm just going to come to my calculator, and I'm going to go second square root, and then I'm going to hit second, this little negative, and it puts the answer back into there. So the square root of 83.3 is plus or minus 9.129 equals x minus 4. So what I really have is 9.129 equals x minus 4, and negative 9.129 equals x minus 4. So now I'm going to add 4 to each of those. So that happens at 5.124 negative. Something's wrong, seems wrong with that. Hold on, somewhere I've made a mistake. Just a minute. So you probably saw it, but I didn't. This negative 1.2 should have been negative 12.5. So I'll hurry and rework some calculations, and then we'll get back on track. Okay, so what I've done is I've replaced that 1.2 with negative 12.5. So I'm going to divide each side by negative 12.5. And when I divide 100 by negative 12.5, I get 8. So now I'm going to take the square root of that. So I'm going to come back to my calculator, second square root of 8, and it's 2.828. So I have 2.828 equals x minus 4, and negative 2.828 equals x minus 4. So now I just add 4 over here. So x equals 6.828 seconds. And I'm going to add 4 onto this one. So I'm going to come to my calculator. I'm going to go negative my answer, so that's going to make negative 2.828 plus 4. And that's going to be 1.17. So this is 1.172 equals x. So those are my 2 times. We can go to our Desmos and graph it as well. So if I come to here and I just type that in, so I have negative 12.5 parentheses x minus 4 parentheses squared plus 200. So now I'm going to zoom out a little bit. So there's 100. Maybe I'll zoom in just a hair. So there's 100. So 1.174. And 6 point something. It wiggles too much. 6.8257. So if I look back, 6.827, 1.172. So those are our 2 solutions. And so that's what we're after on that problem. That would be the end. So good luck. After you've done this one, you can take the quiz now as well.